Number 2537, count the number of good subarrays. In this problem, we want to find the number of good subarrays such that there are at least k pair of indices where I is less than j and the value at I is equal to the value at j. Let us look at an example. To solve this, we can use a sliding window and a hash map. So we can expand the window to when it's first valid. So how do we get enough pairs for the valid window? Let's say hypothetically we have just an array of 3's. So how does each amount of 3 correspond to the number of pairs we can get? If we have 1 3, you cannot make a pair. If you have 2 3's, you have 1 pair. If you have 3 3's, so this new 3 comes in, we can have 1 pair, and then this one can make 2 more pairs. So it's 2 plus 1, which is 3 pairs. We have 4 3's, so we have 3 from here, and this fourth one comes in, we could create 1, 2, 3 more. So it's 3 plus 3, which is 6 pairs. If we have 5 3's, this new one comes in, so we have previously 6, and then plus 1, 2, 3, 4 more. So this is 10. If we have we have 6 3's, then this new one comes in, so we have what we have previously, plus 1, 2, 3, 4, 5. So we have 15 pairs in total. So there is pretty much like a pattern here. For every count, it depends on the previous count and pairs. So if we have I count of a value, then the number of pairs for this is I minus 1 plus pre-pairs. And this is the same as the previous count plus the pre-pairs. So for example, when we go from 5 to 6, you have the pairs for 6 is equal to prev count, which is 5, plus the previous pairs, which is 10, and this is 15. So now the question is, how many subarrays does a given valid sub window contribute to the total number of good subarrays? If we say like the first valid window is this, how many subarrays can we make using this subarray as a subset? Well, this is one, this is one, this is one, and this is one. Basically, anything 1, 2, 3, 4. Anything from the right to the end is a valid subarray, and this is given by n minus right. And our right is here, and n is the total number of elements in the array. In this case, it's 6. Our right is 0, 1, 2. So there are 4 subarrays that include this subarray. So this subarray constitutes as 4 to our total answer. Okay, now going back to the original example, how do we solve this? We start out by expanding the window until there is a valid window. In this case, it's going to be from 0 to 2, which has 3 pairs. And we want to keep a hash map of each value corresponding to their count and the pair of number of pairs that they can make. So in this case, we have 3 3's our hash table would have a value for 3, and this corresponds to count of 3, and there's 2 pairs that you can make out of this. And then this is our first valid window. So how many good subarrays does this subarray contribute to the overall answer? This again is the number of elements in the array n minus the right pointer, which is 0, 1, 2. So 3, 6, 7 minus 2 means that this contributes 5. So this subset, we could have 1, 2, 3, 4, 5 of these. So this would be what we add to our answer. Our answer starts out as 0, and we're adding the 5 extra combinations that this valid window provides to the answer. So let's not do this yet. We could do this as we move the left pointer forward. So in the next step, we want to move the left forward until it's invalid again. And each time we move it forward, if the window, we move it forward, we increment the answer by the contribution of this valid subset. So in this case, we now move this left to here, and we increment it by 5, which was what this list of 3 threes contribute to our answer. So answer is now 5. And now this window is invalid, so we move the right pointer forward until it's valid again. And as we move it, so right now we're at 2 3, so this will be updated to count of 2 3s. And how many pairs does this contribute to? There's only 1 pair. So now that's why our window is invalid, because the k is 2 and we have only 1 pair in our window. So now it's invalid, and now add 1 in. A count of 1 1 and 0 pairs with 1. And this is still invalid, and add 3 in. So now we have 3 3s, which gives us 3 pairs, and now it's valid again because k is 2 and this is greater than or equal to 2. So this is a valid window, and since it's valid, we want to move the left forward until it's no longer valid. So we move this 3, and since there's 2 3s now, it's invalid again. Because it's invalid, we also add the number of subsets we can make out of this previous valid one, which is 1, 2, 3, right, is n minus r, 0, 1, 2, 3, 4, which is a contribution of 3 to the overall answer. So now we have answer plus 3, so now it's 5 plus 3, which is 8. And this is now an invalid window again, so we need to make it valid by moving the pointer forward. Add the 2 into the window. This is a count of 1, 2, and 0 pairs for now. And then move it forward again. There's 2 2s. So now there's 1 pair of 2 and 1 pair of 3. So yeah, we also need to keep track of the number of pairs that is contributed. So pairs in the window depends on the previous pairs plus the new added 2. So we have 2 pairs here, and it's valid again, so we need to see how many this contributes. There's n is 7, minus the right, which is also 0, 1, 2, 3, 4, 5, 6. This is only one contribution. So our final solution is a sum of these, which is 9. So apologies, one thing that we needed to track was the number of pairs, and as we add different values in to the hash map, we are tracking the total pairs for all values, not just one value. So that's why it's important to keep track of the number of pairs. And as we remove values to the count, like we remove 3 from here to here, we need to make sure that we're subtracting the pairs. So in this case, once we have 3 removed, we're going from 2 3s to 1 3. The number of pairs is decreased from 2 to 1, and the number of pairs is from 1 to 0. The count of 3 is from 2 to 1. So therefore, the pairs are lost, like 1 pair is lost. We went from 1 pair to 0 pair. So therefore, we have pairs 2 and it becomes minus 1. We subtract 1 from it, so it becomes 1. And this is still invalid window. As we move forward, remove the 1, so this becomes 0, and move the 3 forward. We lose the 3, so this 1 becomes 0, and there's no change in pairs, so the pair is still 1. Remove the 2, so now the right and left are both here, and we get rid of 1 2, so this pair becomes 0, and we have 1 2 here. So this updated from 1 to 0, therefore the pairs are 0 in this window. So how do we get the number of pairs that are lost when we move the left pointer forward? It's given by this formula. Pairs is equal to previous pairs minus the current count. So for example, we have 6 to 5. You have, how do we get the number of pairs? 10 is basically what we have in this previous pairs minus the current count, which is 5, to get this current pairs, which is 10. Okay, now let's take a look at the code for this. We are first creating a dictionary which maps the value to the count for that value and the number of pairs that this value contributes to this window. And our pairs start out as 0. This is the number of pairs in the current window. Our answer starts out as 0, and our left pointer starts at 0. So now we iterate for each right from 0 to n for that valid window, for that sliding window. Value is nums of right, so this is our right value right now. And first, let's pull out what the number of count and the number of pairs that this value have so far. And we update the number of pairs by using the formula that we had before. It's equal to the previous count plus the previous pairs, since this is derived from looking at the patterns. And note that the change in the total pairs is just plus the previous count. Now we update the hash map for this value with the new count, which is +1, since we just got another one of the same value, and the number of pairs is equal to what the previous count of pairs was plus the previous count, and the number of pairs in this window is just plus what the previous count was. So now for the sliding window, if we have a valid window, we want to move the left pointer forward until the window is invalid. We also want to update but add the subarray contribution to the answer at each time the left pointer moves forward. So we're adding n minus right, which is the number of subarray contributions. And then now we move the left forward. By moving the left forward, we're also making sure that we're decrementing the count for that count for that value. So let's first get the value of that that's at the left pointer that we're moving forward, and then get the counts and the number of pairs that this value contributed previously. And now we could say that the current value count is the previous one minus 1, since we're decrementing the count by 1, and the number of pairs is equal to the previous one minus the current left val count from our formula before. And note that the change in total pairs is just minus the current left val count. And now we update the hash map with the new left value after decrementing the left pointer's value. And the pairs is how many we lost from removing that value from the count. And now we shift the left pointer forward. And once we're done, we return the answer. So what is the time complexity for the solution? It's going to be O of n, because we're using a sliding window, and the left and right pointers are always moving forward and never backwards. Therefore, each index is iterated on at most twice. And the space is O of n, because we have the hash map value to count pair, and this hash map, the worst case is when we have all the values in the nums are different. So we're going to be adding every single value in numbers.